I'm going to do 2 links in this one video. So we're going to do this one, and I'm going to go to the next one real fast. So this link, I'm hoping it'll go quickly for you. Right? We're going to identify if these graphs show a linear function, a quadratic function, or an exponential function. Now, you've done all 3 of these. Do you guys remember what a linear function looks like? It's in the name. It looks like a line. What up? All right. And then what about a quadratic function? Do you remember what that looks like, the quadratic? Because the quadratic is actually to the 2nd power. It is a u. What am I saying? Appreciate you. Like that? Okay. And then we did exponential in the first semester. Do you remember the exponential functions? No? So there's growth that looks like this. And then there's also decay, which looks like this. It is rad. All right, so let's try number 1. Okay? What do you guys think for number 1? And you don't even have to get that specific, Isaac. You can just say exponential. Technically, you're right. It is exponential decay. But you just have to say exponential. Go to number 2. No, number 2. This is number 2. This is number 2. Quadratic. See how it's a U? I'm going to go to number 4 first. I'm going to go to number 4 first. I think we're all good on that one, hopefully. It's linear, it's a line. Now, this one, be careful. Oh, be careful. The last one.
What is it called? Is it called decay?
No. It's not exponential. I'm trying to trick you. All right? Here's how you're going to know, right? Do you see, I know it's going to be very subtle, but do you see how this one, there's like kind of an asymptote right there? Right, do you see that? How it has that asymptote? Okay. And do you see this one? How there is no asymptote. It's going on forever. There's no asymptote. So that's how, I'll go, yeah, let me zoom out.
What's the difference?
Okay, I know it's hard to see, but this right here is going on forever. There's no like asymptote that it's following here. There is an asymptote here.
Okay, so that one keeps going straight.
This one keeps going like straight up because there's an asymptote there. This technically, if you want to know what it is, this is logarithmic.
Okay, but
yes, so you're going to write on IXL, you're going to choose neither or no, I don't know, whatever none of the above or whatever it says. Okay? So just be on the lookout for that because they're going to mess you up. You're like, oh yeah, line, quadratic, exponential. Oh, you got one wrong because you're feeling yourself. So stop feeling yourself and be careful. Okay? That's right. Stay humble. Don't be like the Jersey Shore. Okay. Are we ready for the next link? All right, go right into it. Quadratic at the bottom. And then the first one was exponential. And the number 3 was neither. Because you're not going to be able to put logarithmic. So you just choose neither or none or whatever it is. I did put logarithmic because technically that's what it is. But the choice is like neither. Okay. These are all characteristics of quadratic functions. You've done this. You did this in Algebra 1 and you did this in Algebra 2. So you can do this. Ready? Here we go. Number 1. Make sure you flip to the next one if you haven't. The y-intercept is wherever your function crosses the y-axis. And in this case, it's a kind of a special case because what is our y-intercept? It's 0 or 0, 0. Do you know what that word we use for if the y-intercept is at that point 0, 0? Yeah, Minerva. It's called the origin. What up, Minerva? Right? Gosh. Sure. Let's find the coordinates of the vertex. Do you guys know where the vertex is on a quadratic function? Okay, you know? Can you tell me? That's exactly right, the bottom point. But what if, Gabe, it was like this? Then where's the vertex? The top point. What up, right? That's the vertex. Exactly. Wherever the lowest or highest point is, that's the vertex. Okay? So what is this ordered pair? 0. I heard someone say it. -7. You did it. That's it. Oh, we're crushing this. Yes. I know, right? Number 3. It says, what is the equation? Ooh, for the axis of symmetry. Let me draw a quick little sketch right here. Here's the axis of symmetry. All quadratics are symmetrical. So the axis of symmetry splits it right down the middle. So I'm going to split it right down the middle. So it's x equals, I think I heard Natalia say, -2. I don't know if IXL is going to take off if you put -2. They might say incorrect. So make sure you put x equals when it asks for the axis of symmetry. Hello.
Let's take a picture of your class.
Yeah, we're in the middle of a recording. This is great. Catch us live.
Absolutely not.
All right, let's do. Was Minerva? Did you? Sorry.
Yes, I have a question.
kids were like. Okay. Now I'm ready. Okay.
Wait, like we're learning or like?
Yes, we're learning. So you had a question.
Oh, yeah.
What was your question?
Oh, yeah. Okay, y'all can be studious and then y'all can close.
Okay, let's do one where we're actually listening. Okay. Okay. So Minerva, did you have a question?
So, okay, so I'm back to number 1.
Yeah.
The point would be -8.
Ooh, you're talking about the vertex?
Yeah.
If this question had asked about the vertex down here, the point would be 2, -8. That's right, if it was the vertex.
Wait, so then why is it 0, -7?
Because for number 2?
Oh, number 1.
Wait, Liz.
Oh!
Are you good? You figured it out?
Yeah.
Okay.
I'm doing number 2. I was still on 1.
No worries, you're good. We moved on. Were there any questions?
Wait, can you go back?
Yeah, which one? Sorry.
Thank you, Liz.
She was asking, I think her brain was combining 1 and 2.
Yeah, I was.
So I'll just sum up for you. Question 1 is asking for the y-intercept, which is 0, 0. And then just for funsies, Minerva was like, hey, what's the vertex? The vertex is 2, -8. It didn't ask for that, but if it had, it would be 2, -8. Exactly. Are you good on number 2? This did ask for the vertex, which is 0, -7. Got you. Okay. My bad. I was going too fast. Okay. What about number 3? We feel good about that?
Wait. Yeah.
What I was trying to summarize when they walked in was if it asks for the axis of symmetry, that make sure you put x equals a number. So you should be thinking x equals a number for the axis of symmetry. Okay. It'll split it. Okay. Let's do the last one. What is the maximum value of this function? It is the highest point. Now here's where they're going to get you. Because the ordered pair is -4. Is it comma 4? Yeah, -4, comma 4. But if you type that in, you would be wrong. Okay? Because when it says what is the maximum value, it's asking for a y value. So you're just going to type in 4. Okay? Remember, if it opens up, then it's going to ask you for a minimum value. Okay? So if it's same logic, go to the vertex, tell me the y value. All right? Okay, I'm going to stop it here.